Well, thank you very much, Fiona, and thank you everyone for spending a little time to listen to some of my ideas on this. I'm going to talk about climate change as, in a way, an example rather than the only issue. I'm a climate scientist. I've been a climate scientist for almost 40 years. So yes, I have a bias. That's one of my interests. But as Fiona has mentioned, this has led me to looking much wider than that, and in fact the whole concept of resilience requires that, and it's something that I'll raise as we go forward. I'll talk about this as a diabolical issue. This is not my word. It was the word used by Ross Garnaut, an economist who reviewed the climate change issue on behalf of the Australian government last year. And I'll talk about anticipated changes not only to the climate system but energy futures, because these things now are totally interlinked, and then start to introduce a little about the concept of resilience and what that means to me. And there'll be other people there tomorrow and through this week who will have other views and other ideas about what that means for all of us. Garnaut said that the climate change issue is diabolical because it's uncertain. We don't know everything we'd like to know about this. And isn't that true about all of our life? It's fairly common. It's insidious rather than confrontation. It's there, but has it really confronted us? Well, he says that, but in fact, there are people on South Pacific Islands who have left their island because the sea level has risen and they are confronted with it. They've had to go to other places. So I'm not sure I agree entirely with that point of Ross, despite a huge respect for Ross. Long-term rather than immediate, and again the same argument would apply. International rather than, as well as national, and we're hearing about a lot of that now as the countries prepare to get together in Copenhagen later this year to decide what they're going to do about trying to reduce emissions of greenhouse gases. And the bottom line, of course, is that actually if we don't do anything about it, there's a chance that it's dangerous. Yes, this is a diabolical problem. This is what's happened. Many of you have seen diagrams, pictures like this. This is actually what's happened to the mean temperature of the planet over the last 100 years or so. And I had dinner just recently with Senator Fielding, and he walks around with a diagram that shows the temperature of the planet for the last 10 years, and that's got him worried. Well, none of you here, I'm sure, would do that. The variability from year to year and from decade to decade is quite large. We've known that for a long time, and we know in many cases the reason for that. The question is what's happening over the longer term? What is really happening to the planet as we warm up? And I might add that, of course, if you look at my career in this area, for most of the time we did not know it was warming. The same as when it was suggested that the planet would warm as a result of these gases was first discovered in the 1830s. It's not new science. This is what's happened to Australia, both in our atmosphere and in the oceans surrounding Australia. It's warmed by about 0.7, 0.8 degrees Celsius over the last 100 years. Doesn't sound like much. I'll come back to that as an issue in a moment. So we have an organisation called the Intergovernmental Panel on Climate Change, which was set up in the 1990s in order to try to say, well, this is a very complicated science. There's biologists, there's physical scientists, climatologists, all sorts of people. We need to get our act together every 6 years and try to look at the literature, what it says, only the peer-reviewed literature, I might add, not what people think, but what's gone through that process. And these were some of the major points. Nearly 4,000 pages, I might add, I'm summarising here. The temperature has gone up. The temperature of the planet right at the moment is the warmest, at least in the northern hemisphere. We don't have the data in the southern hemisphere for over 1,000 years. And why don't we go back before that? Because we simply don't have good data. The last decade looks like it's been particularly warm all over the Earth. And there are two things that happen that you don't have to have a PhD in climatology to know, that if you warm the planet, you would expect less snow and ice around. The observations show the planet is deglaciating. There was an article in the newspapers only 3 days ago to show that that's actually happening faster than we thought it was from the British Antarctic Division. And the second thing is that if you warm the water, it expands and sea levels go up. Sea levels have gone up by about 20 centimetres over the last century, not because of the melting of Antarctica and Greenland and ice sheets. That's about to happen, but simply because the water's expanded as it's warmed. And then the one other thing that happens is that the carbon dioxide, which is the gas that's causing most of this change, gets dissolved in the surface of the oceans. And that's a good thing, because otherwise it'd be in the atmosphere and everything would be happening faster. The bad thing is that it acidifies the oceans. And we now know that the oceans of the world are about 1/10, this is average over all the oceans of the world, more acidic than they used to be as a result of that gas. So there are certain things that I'll pick up from Ross. Uncertainty. It's uncertain because we don't know for certain about what the climate's going to do. We don't know enough about the climate system to be certain. We don't know what we're going to emit as greenhouse gases into the future because we don't know what technologies we'll have available. We don't know the rates at which the developing world will need more energy, or for that matter, what Australians will need in terms of more energy as we go forward. We don't know all of the responses of the physical world, or for me, as originally trained as a biologist, as Fiona mentioned, what will happen to the biology? Because as I remember very well, working as a biologist in this state, where we had something like 8,000 or 10,000 species in the southwest of Western Australia, and we had about 5 people in the botany department. We never know. We're never going to know enough about those species to be able to anticipate what's going to happen. We don't know for sure how to respond and react to all of those issues. And of course, then there's all the options for energy futures, which I'll talk more about in a moment. And the complexity. The fact is that we're dealing with the probability that things might happen, that maybe these scientists are correct, that this warming is going to continue. And then we're dealing, on the other hand, with the impacts that that will have. And both of these things have uncertainty, but the complexity is that we have to bring this together and decide what the risk is. And each of us in this room will do that, and then we'll decide we think we've got a certain risk if we change the climate by a certain amount, and someone over here will say, but I don't agree with that. And the islanders in the South Pacific will say, I don't agree with that either. I've had to leave. So we have to bring together this complex of determinations of what is really dangerous for us as a global community and for the rest of the living creatures on the earth, for which many of us feel some sense of stewardship. And the systems operate interactively. They don't operate separately as in an experiment in a laboratory, and they're affecting each other. And the knowledge that we require for these is generated, even today, still by and large in highly reductionist, disciplinary-based departments and schools within the universities and so on. I'm not against that. I'm simply saying that it really doesn't always tell us much about what we need to know about these systems, because they are interactive.